I'm Eduardo Sarkis. I'm a physics teacher. I work at Federal University of São João del Rei in Brazil. Um, we are here to discuss about the dynamics of Earth rotation. And I decided to make those videos I'm about to present because I think there is something missing in the science. I'd like to exercise my thinking and share some ideas with you. Maybe it's just a thinking exercise. Maybe it has um, implications for the science and especially for paleontology as we will go in the conclusion of our discussion. So, Uh, we will start stating that Earth's current physical conditions have persisted for a long time, including the dynamics that would have been established since the formation of the Moon. This is what we can see uh, when we watch videos for science dissemination on the internet, when we look at papers. So people, scientists, scholars usually think that the Earth conditions didn't change too much, at least the physical conditions, since 300 million years ago, for example. However, we may come to other conclusions after exploring gravitational relations between Earth and Moon since a very remote past. So we will check if it is possible that 300 million years ago they had the same length as it has today. Okay, and that's our point. So two phenomena result from gravitational interactions between Earth and moons. One is very well known as the formation of tides. The sun has its influence on the tides also, but we will not discuss sun's influence. Um, and that's the thing. Because of the gravitational field, moon uh, pull the ocean waters, and here the drawing is very exaggerated, but um, not only the waters, but also the solid part of Earth, it is longed in the direction of the moon. So this is what caused the tides. And it's very, very well known since Newton, since Galileo was thinking about this. Other thing is not known for a long time as the first one is this moon is distancing and Earth day is lengthening. So again, the drawing is very exaggerated. The orbit, Moon's orbit, is actually a spiral, and each moment Moon is going further away from Earth. Oh, let's see. This idea is well accepted. The Moon was formed after a collision of a celestial body with Earth. Actually, there are three hypotheses, and this one is the most accepted. Okay. Earth had a higher rotation speed in its beginning, and also because of that collision, the speed of rotation speed increased, and you see. But something is missing in these ideas that are well accepted today. When the moon was closer, the gravitational influence on both bodies was much stronger than today. And that's what I think it's not enough considered in the science, at least when we look at dissemination of science on the internet. It may be that the deceleration rate of the rotation speed and the consequent lengthening of the day was much higher in a distant past. And that's our point. We will bring that to our discussion, and we would like to discuss with more details this idea. So, in order to go there, we have to face these questions. How does the moon interfere with Earth's rotation, and how was the moon formed? Because both questions are interrelated. Let's see. There are three hypotheses about the moon formation. The first one states that the moon was formed at the same time as the Earth from the same material. So there were rocks, thousands, millions of rocks orbiting the sun. They came from an explosion, a star explosion, more than 5 billion years ago. And then those rocks started to orbit the sun. And after a time, the attraction, the gravitational field among them started to make them closer. And then they started to collide with each other. And because they have a very high kinetic energy, um, the kinetic energy transformed into heat. And so that's why Earth was very, very hot and still is in the interior of the planet. But in order to the moon be formed by the same materials, they had to have the same density, but that's not the case. Moon's density is 3.346 kilograms per liter, and Earth density is 5.52 kilograms per liter. So this density is very, very, very different, those densities, and so this is a barrier for this hypothesis. The second hypothesis states that the moon was an asteroid that passed close to the Earth and got trapped by Earth's gravity. Uh, the problem is, for this to happen, the moon would passing through here, and then the gravitational field was pulling the moon. But uh, because of the mass of the moon, its mass is very, very high. The moon had to have the precise speed and pass in the precise point, the precise region, in order to this to happen. So the probability is very, very, very low. And because of this, because moon's inertia is very, very high. So this second hypothesis is not well accepted. The third one is the most accepted hypothesis. A celestial body and the order of 10% of Earth's mass, or similar to Mars mass, was formed between Earth and Sun. So we have we had Mercury, we had Venus, and then the third planet, and then the Earth. But this planet, its ellipse was very long ellipse, and then at the end, this planet or this celestial body collided, and uh, uh, and this collision was the beginning of the moon. Okay. This cosmic impact accelerated Earth rotation, and after the impact, Earth was more, the speed was higher, and then the day on Earth was shorter than before. And uh, 10 years later, 10 years after the collision, the debris started forming the moon because in the beginning they were very hot, and 10 years later they had the temperature that could uh, make them uh, got close enough to form the moon. So this is a representation of that collision, this cosmic collision. In this video, the link for the video is here below. I strongly recommend this video. And the other one is type this words there, and you see another video very, very interesting about this subject. And they are saying something different that we are going to say here, okay? They think differently from me. Well, this collision happened 4.5 billion years ago, and they reached 5 hours after the collision. That's the idea. That's the hypothesis, and they got those numbers with big computational exercises. Okay, simulations. Huh? The fragments that were less than 9,500 kilometers away from Earth returned to it. In the collision, there were tons of thousands of debris, and many of them were less than 9,500 kilometers away from Earth. So this rock limit states that exactly, according to the mass of the planet, those fragments that go in a certain distance, they will come back, they will pull back by the gravitational field. But other fragments that were far away from this, the 9,500 kilometers, considering the Earth, those fragments started orbiting the Earth. And those are the ones that formed the moon. Maybe there are much more that started to orbit and then they went out, okay? But it's important that many of them formed the moon, and that's the hypothesis. The moon orbited the Earth on 17 days on the beginning. It was 15 times, the disk was 15 times bigger than it's today, and it was very interesting moon in the beginning. A day would last between 4 and 6 hours, so the scholars are not sure about this data. And moon's initial orbit had a radius of between 22,400 kilometers to 30,000 kilometers. It's very important to our hypothesis, and we'll come back to this data later. Today, the moon is moving away from the Earth at a rate of 3.75 centimeters per year. It's very, very, very small portion, okay? Very, very small. And it's not, it's happening all the time. The moon is distancing from the Earth all the time. And in the end, after 1 year, this is the rate of the this phenomenon, okay? This 3.75 centimeters. At the same time, the day is lengthening at a rate of 0.002 seconds or 2 milliseconds per century. So each century, the day on Earth, it adds 0.002 seconds for each day. Uh, Again, it's not happening in after a century, but it's happening all the time. The Earth, the speed of the rotation is is going lower and lower, but this at this rate, it's almost imperceptible. So here our drawing is showing how would be the solar system in the beginning, in the far past, today, and in the future. So in the far past, as Moon was 15 times bigger than is today, the disk, a solar eclipse would last for hours and hours and hours. And today, the Moon's disk is uh, similar, almost the same of solar disk. So the solar eclipse, we have the darkness on Earth and a part of the Earth, and it's very dark because the moon covers the sun. But in the future, as the moon is going smaller and smaller, this disk, the future, even in the solar eclipse, we will not have that darkness on Earth. Okay. So, in the next video, we will discuss how is this happening? How is this? The moon is, why? Oh, sorry, why? Why is that the moon is going away and at the same time the day on Earth is lengthening? And by discussing this, I'd like to make a point in exploring what I think is missing in the science.